So today we are going to discuss about the numerical problems of superposition of fields, right? So see in your textbook, your numerical problems are on page number 156. Open your textbook and see that your first question on page number 156 as an MCQ question. What is given that first question? The first is given, when an air column in an pipe closed at one end vibrate such that three notes are formed in it and the frequency of its vibration is dash times the fundamental frequency. What you have given? The pipe is closed at one end. So I can say that here is the pipe which is closed at one end. And it is given that the three nodes are formed. So I can say that three nodes at the open end, there is an antinode, and here there will be a formation of three nodes. So see here, I am getting here the formation of three nodes. One node here, second is here, and third is here. And at the open end, here is the antinode. Clear? At that time, you have to see that the frequency of vibration in this particular situation, the frequency of vibration is dash times the fundamental frequency. That you have to clear. Now, when the pipe is closed at one end, at that time, the fundamental frequency is nothing but P is equal to 4L. This is nothing but the fundamental frequency. Now that fundamental frequency and frequency of vibration in this situation, that you have to concentrate, you have to consider here for that particular case. Clear? So now, what I can say here, in this particular case, I can say the total length L is equal to, see here, how many loops? One loop, two loop, one loop, two loop, and half loop means two and half loop. Two and half loop means what I can say that lambda dash by 2 plus lambda dash by 2 plus lambda dash by 4. This is the total length. So how much is total length? L is equal to, I can say lambda dash by 2 plus lambda dash by 2. That is lambda dash plus lambda dash by 4 means here is 5 lambda dash by 4. So lambda dash is equal to what? 4L divided by 5. This is the value. So now frequency, I can say N dash, which is equal to nothing but V upon lambda dash. So I write down here V divided by lambda dash is 4L upon 5. So I say that it is 5V upon 4L, which can be written as 5 into V by 4L. And your V by 4L is nothing but fundamental frequency. So what I say here, your N dash is equal to 5 into fundamental frequency. So in this mode of vibration, your air column will vibrate 5 times the fundamental frequency. The 5 times the fundamental frequency means your option number D is your answer. Clear? Okay. Fine. Next, your second one is, if two open organ pipes of length 50 centimeter and 51 centimeter sounded together produces 7 beats per second, and you have to find out the speed of sound. Clear? So now you have to find out the speed of sound. Speed of sound means you have to determine the value of V. That is the velocity of sound that we want to determine. And for that purpose, what you have given? You have given the open organ pipe length. Open organ pipe length means what? Pipe is open from both the ends. And when the pipe is open from both the ends, I will say that first length I will say L1, second I am going to say L2. So your L1 length. What is your L1 length? 50 centimeter. And the second length is nothing but 51 centimeter. Means what we can say here? Your L2 is greater than L1, right? Means your vibrating length and your frequency, they are inversely proportional to each other according to your sonometer law, right? So what I say here, your N1 frequency is greater than that of your N2 frequency. And what you have given, one more thing in the problem, you have given bit frequency per second. Bit frequency is difference in the individual frequency, that is N1 minus N2 is given as a 7. So this much data is given to you and you have to find out the velocity of sound. So for that velocity of sound, now I can put the values. Clear? So now here velocity V is N1. This N1 I can write down. And what you are given that? Pipe is open at both the end. Pipe is open at both the end. Here. In that case, you have given the organ pipe length. Means in this fashion, you are getting like this. Here I am giving the first one. So what I said here, this pipe length L is nothing but your lambda by 3. Is what I can say that L1 is equal to nothing but lambda by 3. Here I say lambda dash. Is it right? So what I say here, lambda dash is nothing but as a 2L1. Second pipe length is given what? 51 means this lambda bar, you are knowing here L1. What is L1? That is known to you. So from that I can find out lambda 1, lambda dash. So I say that this lambda dash is equal to 100 centimeter. Is it right? Similarly, now I can find out second is given to you. So for that second case I can find like this. Second mode of vibration. Means in that I'll say L2 is nothing but your lambda double dash. So what I'll say that your L2, which is given as a 51 centimeter, that is your lambda double dash. And now that value we are going to use here in the frequency formula. In frequency formula, what I can say that V divided by lambda dash minus V divided by lambda double dash is equal to 7. So what is remaining now here? I can say V factor I can take common inside the bracket. 1 upon lambda dash minus 1 upon lambda double dash is equal to 1 by 7. So, not 1 by 7 it is 7. Clear? And now we will solve this. What you have? Lambda dash is nothing but 100. Lambda double dash, which is nothing but 51. So that value we are going to substitute here and we can find out the. Clear? So like that manner, you will get your velocity answer. And your option will be answer you are getting as a C option. Fine? Okay. Next. After this, your third MCQ is given. In that, you have given tension in an piano wire is increased 25%. So piano, in that piano concentration, it is air column concentration, air column vibration. So tension in the piano wire is increased by 25%. Its frequency become dash times the original one. Clear? Means you have to relate here frequency and tension. And in vibrating wire, we have seen the second law, which is nothing but the tension law. What the tension law is there? Frequency is directly proportional to root of T. This is your tension. Now this tension law you can apply. Now if I am saying that here they have given as a original frequency. For original frequency I will say N4 is directly proportional to under root of TO. TO is the original tension. Then final frequency NF is directly proportional to TO. Like that manner I can write down. Right? This I am calling equation 1, this I am calling equation 2. Fine? So I will take NF upon NO is equal to root of TF upon TQ. So, under root of TF, now I have to put the TF value. What they have given, tension is increased by 25%. Means your final tension TF is T0, original tension plus 25% of original. 25% means 25 by 100, right? So here 100 is multiplied, 100 TO plus 25 TO means it is 125 TO. So what I am getting 125 TO upon 100, which I am going to write down 5 by 4, right? So that value I am going to substitute as a TR. So 5 by 4 TO divided by TO. So TO factor will get cancelled. What is remaining now? NF is equal to NO. This NO I have taken here multiplication. Under root of 5 by, is it right? And what you have given here now? You have to find out the original frequency. Is what I am getting here. NO under root of 5 by 4. 5 by 4 is 1.25 square root. And this 1.25 square root is nothing but equivalent to 1.12 and 4. That is original frequency. So that is nothing but your final answer. Means your answer is nothing but here B option. Got it? Fine. Then next, the question number 4. Which of the following equation represent a wave traveling along the y-axis? Now, when wave is traveling along y-axis, so there is a vibration. Displacement is along x-axis. So your displacement is along x-axis and displacement along x-axis. That equation will be given only by your option A. See here, option A, x is equal to A sine ky minus omega t. Because your wave is traveling along y-axis, so vertically, so displacement is along x-axis. So your means vibration is along y-axis, amplitude is along x-axis. So your equation will be in terms of x, and x equation is only one. That is option number A. Fine. Next, then fifth one. Standing wave is produced on a string fixed at one end while other end is free. The length of the string is clear. Now, what I can say that standing wave is formed on a string whose one end is fixed. Here one end is fixed. And string is vibrating up and down. Means at the other end there is a formation of antinode. So whenever I am going to say that the node will be formed at the rigid support, so the wave will be formed in this manner only. Right? Means now here what I can say that this up till this first node to second node, this distance is nothing but your lambda by 2, and this distance is nothing but your lambda by 4. If I add these two distances, what I am getting here, this distances will be become as 3 lambda by 4. Lambda by 2 plus lambda by 4. So this distance I am getting as a 3 lambda by 4. See here, is it correct or not? 4 lambda by 2 plus lambda by 4. LCM is 2. So here I am going to multiply by 2. So 2 lambda plus lambda, that is 3 lambda by 4. So what I am getting here, string length is equivalent to what? 3 number. 3 is an odd number. So length of the string is odd integral multiple of lambda by 4. So see that which option is there? Option number A, it must be odd integral multiple of lambda by 4. Clear? So now this 5 MCQ has been finished. Now next, answer question number 2. Answer in break. What you have given here, the wave is represented by equation. The wave equation is represented here. I can write down that equation. So equation will be represented as you are given y is equal to a sine in bracket, it is given Cx plus Ct. This equation is given. Given that the constant A, B, C are positive, all constant are positive. Can you tell in which direction the wave is moving? Now, actually, whenever we are writing equation, what we are writing, y is equal to k sine px minus c. Like that manner we are writing the equation. In that, your wave is traveling along the positive x-axis. But here in the equation, you have plus sign, means your wave is traveling along the negative. Got it? Fine. Next. Then, question number 2, 3, 4. They are the theoretical question. So that you have to solve. Now see the question number 5. In question number 5, you have given the equation. You have given the equation. Here, what type of equation is given to you? So just take that equation. You have given the equation in terms of y. Y is equal to 0.2 sine 2 pi, sine 4 pi, in bracket it is given p upon 0.08 minus x upon 0.8. In SI unit. SI unit means your displacement is in terms of meter. Fine. Then find wavelength, frequency and amplitude. You have to find out wavelength, you have to find out frequency, and at the same time you have to find out the amplitude. Now whatever you have given the equation, you have to check that whether your equation is in the standard form or not. Now what is your standard form? Your standard form of equation is y is equal to a sine of 2 pi in bracket small t upon capital T minus x upon lambda. This is the standard equation. So you have to compare your standard equation with given equation. So your given equation, this is your given equation here. So that given equation I can write down. Your given equation is this upper one first, and this is your standard equation. So standard equation and given equation. Equation number 1 and equation number 2. If I compare, see here. Standard first term y is equal to a. Here is 0.2. Then here sine of 2 pi. Here is your sine of 4 pi. Means this 4 pi anyhow I have to make it 2 pi. Clear? So how I can make it here? See here. Equation 1 I write down y is equal to 0.2 sine of 2 pi and one more 2. This 2 multiple I will take inside. So what I am getting 2t upon 0.08 minus 2x upon 0.8. Equation remains same. So my equation will become y is equal to 0.2 sine of 2 pi in bracket t small t divided by 0.04 minus x upon 0.4. Get it? Now this is my standard form of equation. So now compare equation 2 and 3. Here y, a is 0.2 and what is it? A is the amplitude. Means I am getting first answer. Amplitude is equal to 0.2 and it is given, it is expressed in terms of SI unit. Means it is 0.2 meter. Next, what is next? Lambda. See here. Lambda where I am getting x upon lambda. See here I am getting lambda x upon 0.4. Means what I am getting next value? Lambda is equal to nothing but 0.4 meter. Fine? Then frequency. What is frequency here? M. Now instead of frequency I am getting here period. What is period? Period is 0.04. So I will say period is equal to 0.04 second. So what I will say frequency, which is equal to 1 upon period, can be written as 1 upon 0.04. So 1 upon 0.04 means it can be written as 100 upon 4. And 100 upon 4 is nothing but 25. Means what I am getting? Frequency here I am giving the. Got it? Always prepare such type of equation in proper manner. Clear? So here compare your given equation with standard equation, and from that we can get the values of amplitude, wavelength as well as frequency. Fine? Okay. Then next is nothing but is your, now I can say that here is the your equation, standard equation we have finished. Now directly your numerical problem will start from problem number 10. Clear? So now I can say problem number 10. So problem number problem number 10. In that problem number 10, the wave of frequency you have given as a 500 hertz is traveling with a speed of 350 meter per second. So you have given frequency which is equal to 500 hertz, and it is moving with speed. Speed is nothing but 350 meter per second. This is nothing but the speed. Now what is the question first asked? What is, you have asked first, what is the phase difference? You have to answer for the phase difference between the two displacement at a certain point at a times 1 millisecond apart. Right? So now for phase difference, for a phase difference for time interval 1 millisecond. Now how we can calculate that? For that we have to write formula for phase difference. So your phase difference which is equal to 5. This phase difference which is equal to 5 can be written as 2 pi divided by capital T into C. In that you have to write for period. Same formula I can write down 2 pi n into T. N is nothing but the frequency, and you have a frequency 2 pi. What is n? N is the 500 hertz frequency multiplied by time is 0.1 millisecond. 0.1 millisecond means 0.1 into 10 raised to minus 2. That is only given time 1 millisecond. So here it is 1 millisecond. So I say that 2 into 500. 2 into 500 is nothing but 1000 multiplied by 10 raised to minus 3. Now this 1000 I can write down 10 raised to 3. 10 raised to 3 and 10 raised to minus 3, that will get cancelled. So what is remaining? Your phase difference answer will be nothing but 5. Clear? Such type of questions will be there in your very short answer or MCQ question. Then also you have to answer what will be the smallest distance between the 2 points which are 45 degree out of phase at any instant of time. So you have to find out the smallest distance, right? So for smallest distance, you have to find out for the smallest difference, you have to find out the smallest distance. So for smallest distance, right, what you have given phase and the difference is given. Pi is given 45 degree. This 45 degree I will convert into radians. So 45 degree into radians, that is nothing but your pi by 4. That is given. Okay, and now you have to find out the value of x. So I say that phase difference pi is equal to nothing but 2 pi x upon for smallest distance. So what I write, x is equal to nothing but pi lambda upon 2 pi. Clear? Now lambda is not given in the problem, but in the problem you have given frequency which 100 hertz. And also you have given the speed. Speed is given 350 meter per second. So from that we can find out the lambda. So this lambda is equal to nothing but V by N. What is V? V is 350 upon 500. So this 0, 0 will get cancelled. So it will be getting as 35 upon 50. So 35 upon 50 is 7 by 10. That is nothing but value of lambda. So that value I can substitute here. So 5 is definitely plus lambda by 4. Here it is 0.7, 7 by 10 means 0.7 divided by 2 pi. So this pi factor will get cancelled. So what is remaining here? 0.7 upon 8. So we can solve this 0.7 by 8. So it is 0. Now 0.7 divided by 8. So 8 8s are 64. 6. So it becomes 60. Right? Then I can say that your next is nothing but 7 8s are 56. So here is 7. Next is 5. So this much I am getting as the smallest distance. So 0.7 upon 8 is nothing but your 0.875 meter. So in that smallest distance, you will get it your phase angle difference, which is nothing but pi by 4. Get it? Any doubt up till this? Okay. Then see the problem number 11. In that 11th problem, you have given sound wave in a certain fluid medium is reflected at an obstacle to form a standing wave. The distance between two successive nodes is 3.75 centimeter. If the velocity of sound is 1500 meter per second, then find the frequency. Get it? So in the fluid, there is a formation of standing wave. And in that standing wave formation, always there is the formation of node and antinodes alternately. And what you are given in the problem, you have given that is distance between two successive nodes. Now distance between two successive nodes, you have that formula, distance between two successive nodes is nothing but lambda by 2. And this distance, this lambda by 2 distance, which is given as a 3.75 centimeter. It is given. So from that I can find out lambda. Lambda is 2 into 3.75 centimeter. I convert into meter. So 10 raised to minus 2. This much is the value of lambda. And you have given the velocity of sound. Velocity of sound V is given 1500 meter per second. And what you want to find out? I want to find out the frequency. Okay. So what I write formula? N is equal to V by lambda. So now your V is 1500 divided by lambda. Lambda is 2 into 3.75 into 10 raised to minus 2. Right? So now you can see here what values I am getting here. So I will do the multiplication. Fine. So V is your 1500 and this 2 into 3.75. So 3.75 into 2. That you have to do the multiplication. See here what I am getting here. This minus 2 goes into numerator. It becomes plus 2 upon 2 into 3.75. 2 5s are 10. 1 carry. 2 7s are 14 plus 1 15. 1 carry. So 1500 into 10 raised to 4 means I write 15 into 7.5 into 10 raised to 4. So 15 divided by 7.5 is divisible by 2. So what I am getting 2 into 10 raised to 4 hertz. Right? Means in another language what I write 20 into 10 raised to 3 hertz. From 10 raised to 4 1 0 I will take out, it will become 20 into 10 raised to 3 hertz. Means which is equivalent to 20 kilohertz. So that is nothing but your frequency. Clear? So if you will come to know, if you are solving some 5-6 problem, every time we are using the formula, that is B is equal to M lambda. So in this chapter, you have to remember this formula very carefully. That is velocity is equal to frequency multiplied by lambda. That is B is equal to M lambda. Clear? That is nothing but your problem number 11. Now we can go for your problem number 12. So see that in problem number 12, if you are seen carefully, in problem number 12, you have given two sound sources are separated by the distance of 4 meters. So you have given two sound sources, and that two sound sources are separated by distance of 4 meters. They emit sound waves of same amplitude and frequency of 330 Hz, but they are 180 out of phase. इसका मतलब क्या है? अगर मेरा एक साउंड वेव यहाँ से है, तो मैं बोलूँगी साउंड वेव मीन्स कॉम्प्रेशन, देन रेफ्लेक्शन. ओके, मीन्स यहाँ से यहाँ तक completely. So what I am getting? Out of they are 180 degree out of phase. इन दूसरा वेव कहाँ से मेरा सिस्टम? यहाँ से कॉम्प्रेशन, यहाँ से रिफ्लेक्शन. तो ये वेव कैसे है? यहाँ से कॉम्प्रेशन एंड तक. One compression and one reflection means your one complete wave, and one complete wave means your phase angle is 360. Means यहाँ से यहाँ तक phase angle कितना हो गया? 180. तो ये मेरा first sound wave है, ये मेरा second sound wave. They are opposites. Getting? उसके आगे their amplitudes are same. They have a same amplitude, but and they have a same frequency. Frequency is given 330. Amplitude is same, frequency is same. Now, what I want to find out? I want to find out the point between the two sources. Will the intensity be maximum? Means at what point I will get the intensity maximum. Now, sound intensity is maximum means what? The point where displaced amplitude is maximum. And when two sound waves will get superimposed on each other, there will be a formation of node and antinodes. Right? So at antinodes, what I am getting? At antinodes, amplitude is maximum. If amplitude is maximum, means automatically the intensity is also maximum. Amplitude is maximum, intensity is maximum. Means I have to search the distances where antinodes are formed. And already we have seen that in the derivation. That is, your antinode will be formed at a distance of lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. Already we have seen the derivation. And using that derivation, just I'll find out the value of lambda. Right? And उसमें क्या दिया आपको? Already frequency is given. You have given the frequency. So I can find out here. I can find out here as velocity. So standard velocity of a sound is 330 meter per second. This is the standard form of velocity of sound. So V is 330 meter per second. Frequency is 330 hertz. Means I will say that formula is V is equal to M lambda. Therefore, lambda is equal to V by N. So velocity is 330. Frequency is 330. Means lambda I am getting 1 meter. And if lambda is equal to 1 meter, means what I say that x is equal to lambda is 1 meter. Means what I am getting 1 by 4. Next is 3 by 4. Next is 5 by 4. 1 by 4 means what? Plus minus 0.25. comma 3 by 4 means plus minus 0.75, comma plus minus 1.25. So at this location, what I will get it? I will get amplitude is maximum, where I will get the antinode. And when antinode is formed, amplitude is maximum and the sound intensity is also maximum. Got it? Any doubt up till this? Everything is clear? Okay, fine. Your next question, that is problem number 13. Two sound waves travel at the speed of 330 meter per second. Means you have given the speed of sound. How much given? The speed of sound is given as a 330 meter per second. So that data I will write down first. Speed of sound V is equal to nothing but 330 meter per second. That is the first one. Second thing is given, if their frequencies are also identical and equal to 540 Hz. The second data is given, frequency is equal to 540 Hz. Fine. What is next thing is, what will be the phase difference between the waves at the points 3.5 meter from one source and 3 meter from the other if the sources are in the phase? Clear? So you have given the source distance. एक का distance x1 is given 3.5 meter और दूसरे का distance दिया है x2 is equal to 3 meter. Right? And you have to find out what will be the phase difference if that two sources are in phase. In phase का मतलब क्या है कि दोनों sources same plane में, same vertical plane में. So both the sources are in the same vertical plane. So what I say that phase difference phi is equal to 2 pi x upon lambda. But दोनों sources का आपको distance difference दिया है. What is that? So I write down 2 pi into bracket x1 minus x2 upon lambda. Now there is a need to find out the value of lambda. And how I can find out the lambda? I am knowing velocity, I am knowing the frequency. So I write the formula, initial formula, V is equal to n lambda, therefore lambda is equal to V by n. Clear? Now velocity is given 330 upon 540, 0 cancel, number is divisible by 3. 3 11 and here 3 1s are 3 8s are so 11 by 18 meter. So I put this value now here. So what I am getting 2 pi x1 minus x2. x1 कितना है मेरा 3.5, x2 कितना है 3. So 3.5 minus 3 means यहाँ पे आएगा मेरा 0.5 divided by 11 multiplied by 18. Get it? Now see that 2 into 0.5 कितना आएगा 1. 1 into lambda into 18 means what is it? 18 pi upon 8. इसको solve करेंगे. 11 1s are 11, 7 बच गया, 70 हो गया, तो 11 6s are 60. Clear? तो यहाँ पे 11 6s are 66, 70 में से 66 गया, means अंदर बचा 4. Right? तो यहाँ पे मेरा क्या आ गया इसके बाद 3. Because कितना बचेगा 40 to 11 3s are 33, तो 7 बचेगा, वापस आएगा यहाँ पे 6. Fine. मीन्स मेरा अप्रोक्सीमेटली आंसर कितना हो जाएगा 1.645. तो ये आ गया मेरा 3. That is 5. Got it? So whatever problem yesterday we have seen, today we have seen, इसमें कौन से दो important फॉर्मूले यूज किए हैं? V is equal to n lambda. दूसरा phi is equal to 2 pi x upon lambda और 2 pi small t upon. ऐसे फॉर्मूले हम लोगों ने यूज किए. So remember this thing very to solve the problem regarding superposition. Get it? Okay. Now remaining numerical problems you can see in the next. Fine. Chalo. Thanks.